Okay, everybody, how are we doing today? So, we've been working on different counting techniques. Remember combinatorics, this idea of how many ways can we do things. So up to this point, we've looked at permutations and combinations and thrown the factorial in there. So this last section here, it's called counting without counting, which is just a fancy way of saying use the formulas that we've been using. So this is just another way of saying combinatorics. So we just want to look at some kind of random examples and see if we can figure out how to decide how to do them. Okay, so a little reminder from the last couple times. Remember that a permutation, in a permutation, we have that order matters and no repetition. Order matters and no repetition. So the way that you line up to buy something at the store, okay, the order matters. If you're first in line, woohoo. If you're last in line, you're not as happy. Okay, so then remember a combination has no order, but there's still no repetition. No order, no repetition. So remember, that's where we're selecting like a committee. Okay, we're not electing a president and a secretary, we're selecting a committee to put on a bake sale. So we say, hey, the two of you go put on a bake sale. It doesn't matter whose name was said first, okay, the order doesn't matter. Okay, so we have the combinations and the permutations, but then the other thing is that there could be examples that are both neither or both. So sometimes you might have a combination combined with a permutation, and other times you might have something that just doesn't follow either one of these two. So it's definitely possible to see a neither situation going on. So let's go ahead and look at a neither situation just so you see what I'm talking about right off the bat. Okay, so let's say that we need to look at license plates. So we are DMV and we produce license plates. Okay, now in most states, not in our state, but in most states, a license plate has 6 slots on it. Sorry, not very symmetrical there, but anyway, go with it. Now, depending on what state you're looking at, it's either going to be 3 numbers followed by 3 letters, or flip it around, 3 letters followed by 3 numbers. Okay, so we want to know how many license plates are there that have 3 letters followed by 3 numbers. Okay, so what we need to think about, and I want you to think about license plates that you have seen. When we look at a license plate, okay, the order of it definitely matters, right? The order that the letters and numbers come in makes a difference, but can we have repetition? So my license plate has repetition on it. It has 2 9s on it, okay? So it is a permutation in the sense that order matters, but then it fails being a permutation because permutations require no repetition. So this is an example of a situation that's neither. Now, does that mean we can't do the problem? No, it just means we have to think about it a little bit. So what we want to do when we're looking at a problem like this that falls into the neither category is go back to the pigeonholing method. That's always your kind of go-to. If it doesn't follow your rules, go back to the pigeonhole. Okay? So what we would say is set up 6 slots. These first 3 are letters. These second 3 are numbers. And we know that repetition is okay. So if we start here with letters, how many letters are there to choose from? And we're not doing any of like the hand or the heart or those special weirdo little things. They're basic letters. So there should be 26 options for the first slot. But because repetition is allowed, that means that the second slot is also 26, isn't it? And the third slot is also 26. Okay, so it doesn't cycle down because of that repetition. Now we come over here and we think about numbers. Okay, now don't get yourself caught on this. How many digits are there? Okay, it's not 9, it's 10, right? Don't forget about 0. So for 0 to 9, so there are 10 options. And again, there's repetition, so there's 10 options for each one of those. Now remember, the counting principle says that we're going to multiply here. So this is going to be 26 to the third power times 10 to the third power. And, where's my calculator? Over here. I get 26 third power 1,757,6,0,0,0. Okay, so over 17.5 million license plates start with 3 letters and then are followed by 3 numbers. So there are over 17.5 million license plates that could be made. Now, in a lot of states, that's plenty, okay? Because those states are not as big as other states. But in our state, is that enough license plates? Okay, it's not. So what happens is, in state, they calculate this and they say, oh, it's over 17.5 million. That's plenty for our state. We're good to go, okay? But in a state like California, we go, no, this won't work for us, okay? This is too small for us. So we need to have license plates that have more digits on them, okay? So our license plates in California and again, we're not talking about the vanity plates or that kind of thing, just the basic license plates. Let's see, they're a number. Geez, this is bad. I used to know what they were. How do I not know my license plate anymore? Okay, yeah, sorry. A number followed by 3 letters, followed by 3 numbers. Sorry. Woo. Okay, so our license plates have 7 slots, 4, 5, 6, 7. Okay, and then what did I just say? A number followed by 3 letters, followed by 3 numbers. So we decided that this part of it wasn't enough. The 17.5 million wasn't enough, so we slapped another digit on the front. Okay, so if we want to see how many license plates there are in this situation, again, repetition is okay. So for that first number, there are 10 options. Then 26, 26, 26, and then followed by 10, 10, and 10. Now, the only way this is going to differ is by taking this number and sticking another 0 on it. So there will be a total of 175,760,000. Okay, slap another 0 on that. And that looks like a lot more license plates, okay? So 175 million license plates can be formed when we use this arrangement. But the funny thing is that in California, that's still not good enough, okay? Still not good enough. So this is the license plate arrangement if you drive a car in California. But they decided, well, we still need more license plates. We can do all these different arrangements, but we still have more cars on the road than there's license plate numbers. So then what they did is they decided to make a different license plate for trucks, okay? And a truck license plate, okay, has a little bit different form. It still uses 7 slots. So 1, 2, 3, 4, 5, 6, 7. But this goes a number followed by a letter, and then number, 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 number. So different arrangements. So again, the numbers are all going to be 10s, yes? and the one letter will be the 26. So this time, this is gonna be 26 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Boop, boop. Okay, so by creating specific truck license plates that look different than the car license plates, we were able to add 26 million license plates to the original number. Okay? But guess what? And this happened in about the last 10 years. In the last 10 years, all of a sudden, this extra 26 million license plates that we had for trucks, not good enough anymore. There are now too many trucks on the road in California to use this 26 million. So guess what they did? They went one step further and said, or let's do it this way. So 1, 2, 3, 4, 5, 6, 7. And new trucks with new license plate numbers now look like number, 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 letter, number. Okay, so they just kind of flipped it around. So the first truck that I owned when I got my driver's license and got a truck, my license plate looked like this, 4F69987. Okay, so that's that. My new truck, the license plate looks like this, 93509X1. Okay, so the license plate has shifted a little bit, but again, this is still a bunch of 10s with a 26 and another 10 going on. So this adds to it another 26 million truck license plates. Okay. So now we have 52 million extra truck license plates. But like we were saying, in smaller states where this is good enough, they don't even have to worry about it, okay? North Dakota, they don't have to worry about it. It's always 3 letters, 3 numbers, no big deal there, okay? Hawaii, 3 letters, 3 numbers. It's not ever going to max this out, okay? They're always gonna be good to go. But in our big states, like our state, all of a sudden it's like, oh, wait a minute, that doesn't even work. We need extra license plate for trucks, and we need extra license plates because we used all the truck license plates. Okay, and then we've got all those vanity plates and all of the little special figures that you can put on your license plate. But this is how we look at creating, well, in this case, license plates or different arrangements and how many we need to include. So it wasn't just someone who said, oh, hey, let's make it 7 digits long just for the heck of it. They realized they needed to make it 7, not digits, but 7 spaces long. Okay, so let's look at telephone numbers. Ten-digit phone numbers. So how many 10-digit phone numbers are there? All right, so when we look at phone numbers, and we want to think about this, our phone number, we have an area code, then the first 3 numbers, then the last 4 numbers. Now, back in the beginning, when phones were brand new, 130 years ago or whatever, they didn't have phone numbers like this. Honestly, what you would do is you would call up the operator and you would say, give me Atascadero 24. And what that meant was you wanted the person in Atascadero with the 24th phone. So the first person in Atascadero that got a phone, they were 24, or they were Atascadero 1. Atascadero 24 would have been the 24th person in town that got a phone. Okay. Well, obviously, as people started to get phones, that started to get a little bit tedious. You wouldn't want to hear, get me Atascadero 4,332. All of a sudden, it's like, oh, wait a minute, this is too much trouble. So that's when we started to actually create phone numbers. So these last 4 digits, that is kind of like the beginning start of the phone number, way back from, again, like 130 years ago. These numbers here, though, these were supposed to tell you something. So instead of calling and saying, find me a Atascadero, blah, 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 these three numbers here were supposed to show you what city you were talking about. So instead of saying Atascadero, you would type in three numbers. So in Atascadero's case, that's going to be like 466, 461, something like that, because that's what Atascadero numbers look like. So they replaced the word with these 3 digits. But then they found out that even with these 3 digits, people are getting more and more phones. And then they included the area code. And the area code was again supposed to tell you not what city you were in, but more what area of the country, or almost like what county. It goes a little wider than counties, but what area of the country you're in. Okay, so instead of saying California, Atascadero, telephone 24, you'd have like 805 466 and then your number. So the area code and the city code. Okay, and then if we want to even get into this further, we could add more and go for the country code. Now, if we're looking at a 10-digit phone number though, in the United States, right? So 10 digits, so no country code on the front. There is repetition, isn't there? Yes? Okay, so repetition is definitely allowed, but we want to be very, very careful with this. If you pick up the phone and you dial 0, okay, so if the first digit is 0, what's happening? You're going right to the operator, right? So that means this first digit of the phone number cannot be 0. It also can't be 1, okay? So we can't have 1 there. So when it comes to phone numbers, this first digit doesn't have the choice of all 10, does it? It only has a choice of 8, because it can't be a 0 or a 1. So there are only 8 options there. So we say no, 0, or 1. Now, after that, we're good to go. We're good to go until we get here again. Once we get here, this number also can't be a 0 or a 1. Okay, so we say no, 0, or 1 for this number as well. So that's an 8, and then a 10, 10, and then for everybody else, it's just a 10. Okay, but when you dial that phone number to start with, that first number has to be something other than 0 or 1, or you're looking at like calling outside the county or calling the operator. So when we look at this, if we want to know how many 10-digit phone numbers there are, the 8 times the 8 will give us 64, and then we've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. 8. Okay, so it looks like we're looking at 6.4 billion phone numbers, 6.4 billion phone numbers. And there was probably a long time, or we know there was a long time when that was good enough, right? But 6.4 billion phone numbers isn't going to cut it anymore. It's not going to cut it. So that's why if you're calling outside the country, you've got a 3-digit country code that would go on the front here. Okay, now that 3-digit country code just ups the number of options that you have, or that we have for how many phone numbers there are, because otherwise we would have repeat phone numbers. So this is a way of again, figuring out how many there are without actually listing all 6.4 billion phone numbers. That's not going to happen. You're never going to list those. But we know that there are 6.4 billion different ways it could happen, okay? Even though we'll never list them all. Okay, so those are 2 examples, license plates and phone numbers. Those are some examples of ones that are neither permutations or combinations, okay? But we can still do it, we just kind of fall back on the fundamental counting principle. Okay, so let's look at another one. So, a choir has 4 sopranos, 6 altos, 5 tenors and a bass. A quartet is needed with one of each. How many ways can this happen? Okay, so a choir that has sopranos, altos, tenors, and a bass, they need to put together a little quartet to do, some little thing, and they need one of each of those. So we want to know how many ways this can happen, okay? So when we look at this, we're choosing one of each. So we can always kind of try to start off with the pigeonholing. Okay, try to start with the pigeonholing, and then we'll say that we got soprano, alto, tenor, and bass. Now, there's definitely going to be no repeat, right? Because you can't be in both groups at the same time, all right? But this is not one that we need to use the permutation formula or a combination formula. We can just go ahead and use the pigeonholing method here. So if we're going to choose a soprano, how many options do we have for a soprano? Okay, and there would be 4 of them, wouldn't there? Then we need to choose an alto from the group, so there are 6 of those. We need to choose a tenor, and then we need to choose a bass, but there's only one bass, so that's kind of set in stone, isn't it? So what we need to do is multiply these numbers together, but notice how they come in no order. It's weird because of the way the problem was given to us, but we can still solve it. So here we get, what do we get there? 20 times 6, so 120 ways. Okay, so what if they need a soprano, 2 altos, 2 tenors, and a bass? Okay, so we're no longer looking at a quartet here. We're going to add 2 more to it. So we're looking at a sextet. Okay. All right. Now this is going to change things a little bit. We still are going to have 4 slots. Okay, still 4 slots going on. But when we look at each one, the numbers are not going to be as easy anymore. Now for soprano, we still only need 1 soprano. So how many options do we have for a soprano? We've got 4 options, right? But here's where things change. We need 2 altos. There were 6 altos in total, and we need to choose 2 of them. Okay? Now, does the order that the 2 altos are chosen in, does it matter? Or are they just both going over there to sing over there? So here, what we're looking at is inside this problem, there's a combination. So we've got 6, choose 2. We have 6 altos, we're going to choose 2 of them to be in the sextet. Okay. Then we come over to the tenors, and we need 2 tenors as well. Now we have 5 tenors in total, we need to choose 2 of them. So 5, choose 2. And then still there's only that 1 bass. So 1 bass there at the end. But this means that these 2 in the middle, we've got to do a little extra work. So we'll get out our old calculator, or if you got Pascal's triangle handy, you can look at them on Pascal's triangle. Oops. So 6, and then math, PRB, NCR2. Okay. So I got that this one is 15. And I got that this one is 10. Okay. So we need to go 4 times 15, which is 60 times 10. So there are 600 different ways that we could select this group to see. Okay. So you have to think really carefully, and that's the big thing when you're doing this, is that you really need to think. You need to ask yourself many questions. So is there repetition? Does the order matter? Can I choose them in any order? Is this a permutation? Is this a combination? Is it neither? There's lots of things to ask yourself. Okay. So let's see what else I have here. Well, maybe that's it. All right, I think that's it. Okay, yeah, so lots of different examples in there to look at, lots of different things. So definitely ask yourself the question each time, what are we looking at there? Is it a combination? Is it a permutation? Is it neither? And then you can, look at the solutions, or if you're unsure, you can always ask, and we can talk through why it's one or the other, okay? So, but definitely something that you have to practice on your own. You absolutely must practice this yourself, because it's one thing for me just to say, oh, notice that this is going to be a combination. It's another thing for you to read the problem and get that yourself. Okie dokie. Alrighty. So we'll leave it at that, and I will see you next time.